A background on myself. My name is Niall Roche. It should have been Roche originally, I guess, but the French has got diluted over here in Ireland. So I'm part of a Web3 venture studio where we look at building startups in the AI and blockchain space. So quite a lot of our work is at the intersection of both of those technologies, and that's what I'm going to talk to you a little bit about today. Is looking at evolution of smart contracts from um, their original origins on chains, private permission chains. Where are we now? What are they good for? What are they not good for? And a whistle stop tour really through a bunch of new emerging technologies that are sort of at the hybrid intersection of using off-chain compute that is verifiable. And this is opening up a number of use cases for distributed ledger technologies in general, while not revealing everything on chain. So obviously, blockchains are very good at having public accountable ledgers, but not everything can be put on chain for a number of reasons. Obviously, compliance being one, we can't put certain data on there. We don't want, from a commercial sensitivity perspective, for everybody to see what's going on. Our alternatives are sometimes private permission networks, which have their own set of difficulties and not very scalable and require a sort of consortium and have a number of different limitations. So what is emerging is a new group of technologies that's trying to balance this transparency and ensuring that that smart contracts basically execute as they're supposed to do, but keeping user data private. So keeping the confidentiality in there. So it's really a collection of different technologies, and I'm going to try to go through this at a very, very high level, just touching on some of the technologies that are involved in this. So this entire area is known as decentralized confidential computing. It's a relatively new space, but it's taking a bunch of technologies that are not very new and pulling them together into an integrated system. So just like AI and blockchain didn't happen overnight and was built upon many different technologies in the past, so are these other related technologies. So trusted execution environments have been around for a number of years. Intel, for example, has been leading the way on a isolated hardware set of CPUs and now GPUs in certain contexts as well that can execute data confidentially, can't be tampered with. There were some high profile difficulties with these in the early stages, but it's an area of research that is really allowing secure computation. We're also seeing multi-party computation, where the computation can be split up across multiple different parties. They can work together to achieve a result. And that is leading into fully homomorphic encryption, where the parties working on the data don't even have access to the underlying data. They're working with an encrypted version of that data, so they don't know what data they're actually processing on. And this is really, really useful for processing large data sets, in particular for machine learning workloads, where you can spread that workload out. But when industries like healthcare and obviously construction, where you've got very sensitive data, that allows flexibility in who can process the data without having to reveal anything that's sensitive. And there's an entire new branch of smart contracts that are getting a little bit of popularity at the moment, using an older approach that's becoming more commercially viable at the moment called zero knowledge proofs. And this allows you to perform some computation and prove to somebody that you have performed that computation, but without revealing the details of that computation. A classic example that's used is, for example, show me that you're over 18, but you don't need to reveal your age. Or something I built with this recently was show me that you have above X amount of money in your bank account to become a accredited investor without revealing to the world what your full bank balance is. So it's a combination of all of these different types of technologies coming together. So can we achieve the benefits of decentralization while keeping the data processed inside these trusted execution environments and using multi-party computation? So there's multiple parties checking the homework, but it's not the same sort of situation where one smart contract is executed by hundreds of thousands of nodes as it would be on a public chain. So it's trying to get the benefits of both approaches. I won't go through all of these. These are you can access this in the slides afterwards. I just want to give you a broad overview of the domain, and in particular, really where that would apply towards construction use cases. So we'll break it down a little bit as to where this these types of technologies could really be applied. So that's the whole purpose: privacy, security, ensure that nobody knows exactly what happened, but we know that the code executed as it was supposed to. And then we have a reference of that going back on chain. And in the case of zero knowledge proofs, other people can verify that this proof, by the proof that the computation occurred and it wasn't tampered with in any area. So we look at some use cases in a little while. So the terms verifiable, confidential computation, decentralized confidential communication, they're all really the same thing. So if you're starting to looking for papers in this space or projects that are in this space, that's the types of types of technologies that you're looking for. It's just the level of decentralization is the difference. So we'll skip past here. So why would we use these? Well, confidentiality is the main reason. In this case, the data remains secret. It's not the same as looking up a Solidity contract and seeing what somebody's account balance is for a number of tokens, or in the case of using decentralized file storage, for example, if you upload plans for a building, obviously, unless that's encrypted, anybody can access that. But now we're starting to see decentralized applications that can start to build these types of technologies out. So we're not just relying on single centralized parties or a small number of nodes as we would have in a private permission network. The cryptography behind this has been very, very complex and has been slow to take off. But we are now starting to see more efficiency. So these systems are becoming more scalable. So this is the real kind of evolution in this space, just as 5-6 years ago in working with natural language processing and machine learning, we've had a massive jump in performance. Hardware plays a part in that, as do new algorithms and new model architectures like transformers, etc. We started to see that shift appear in these types of technologies where they're now more commercially viable. And they're really quite general purpose technologies, and they have applications in various use cases. And some of these are definitely applicable in the construction space. There are some disadvantages. It's still early stage. You may not want fully privacy preserving operations for compliance purposes. You might need to give an auditor or a regulator the keys, for example. But again, multi-party computation can help with that. And another protocol that I've been working on called DREC, or Decentralized Key Recovery, which is an open standard that we're working on with a number of different blockchain providers. So it can be as private as you want it to be, but you can still prove to auditors that you are compliant with the regulations. It's an early emerging stage. So some of these projects I'm going to talk about are at an early stage of their evolution. So some of them have large numbers of nodes, some of them don't have that many nodes, but they will continue to build out. Just like in the early days of blockchain networks, we had the same sort of issue, and we're only getting more and more blockchain networks at the moment. Some of the cryptography behind it does have an overhead. So FHE and ZK in particular are very slow compared to executing just the raw code. So they're not suitable for all cases at the moment, but that is improving, as I mentioned, and will lead to new use cases where they are more suitable. In particular, one area where they are quite suitable is in ZK machine learning, which I'll talk about a little bit later, which is using the applications of a machine learning algorithm which reached a decision point, for example, and you can show and demonstrate a proof of how it got there and that your model wasn't tampered with, which can be really, really useful for compliant machine learning cases. For implementing ZKP, at the moment, it's a very particular set of languages that you need to use that are even more obscure than the languages that you need to use for blockchains. So it's quite low level. There are levels of abstraction coming up. It is getting better for this, but it is still quite a complex programming task and not a general purpose language in all cases, or not general purpose uses. They're kind of a limited set of use, but still can be quite powerful. So let's have a look for construction. Well, definitely transparency in supply chains. Having it can be an issue in certain cases because putting all of that on a public ledger, you might not want that, but you can have this privacy preserving supply chains. Processing in digital twins, I'll come on to a little bit later around where these technologies can be useful for that. Private smart legal contracts for agreement. I normally speak quite a lot about smart legal contracts. My previous presentations at the CBC have gone into that in great detail, so I'm not going to go into that. But we're building a solution at the moment for processing smart legal contracts using privacy preserving techniques like some of the platforms I'm going to mention. So this is real. They are fantastic for this type of use case. And actually, as it turns out, we're using knowledge graphs as well. We're using knowledge graphs and NLP for creating our smart legal contracts, just similar to some of the ontology discussions and the kind of question and answering use case that came up on the previous talks. It's also very good for calculations. So showing that if you have some sort of standard calculation that needs to be performed on, let's say, a steel beam or something, you can show the ZK proof of execution of that so that you can be sure that that calculation was actually performed correctly. I already mentioned zero knowledge ML and proofs, but that's a fantastic area at the moment. It's something we're using on a different venture that we're building at the moment, looking at human machine teaming and what are the agents doing, what are humans doing, and showing proof of what has happened in a particular workflow. Be very useful for certifications, verifiable credentials, where again, you don't reveal any personal identifiable information on chain, but you want to be sure that somebody has the necessary credentials for carrying out some work. Very useful for private voting in DAOs. I remember Gavin, who's up next, spoke quite a lot about DAOs in the past. So this allows you to have private voting without revealing what everybody's vote was, but knowing that the votes were tallied correctly. One extra area where we're using on a different venture we're working with at the moment uses ZK to help with the login flow. So it looks like a Web2 experience, but behind the scenes, you sort of log in with say, Gmail or whatever your normal credentials are, and behind the scenes, it uses zero knowledge proofs and a hidden wallet, basically, to give you a Web3 private key that you don't even know that's there. And that makes that entire experience of using blockchain wallets and various other very high barrier to entry technologies for those using Web3. It makes that sort of more hidden in the background. Many blockchains are using rollups at the moment, which are basically ZK operations that increase the performance. There's all these layer twos that sit on top of Ethereum that are increasing the speed. So behind the scenes, some of those use zero knowledge proofs. And there are many other bits as well. So sealed auctions, this whole DPIN movement at the moment for tokenization allows you to have far more flexibility in what you are tokenizing. So for example, you could have private data for a smart contract, which is actually this one here. So you've got public data, but you also have private data that is hidden away that only certain people can access. In supply chains, as I mentioned, you can have some transparency, but not too much transparency. You can reveal this happened in the supply chain, but not exactly leaking any data online. For digital twins, in particular, the processing of the data that is used to compute the rendering, we start to see a lot of different decentralized compute providers now providing shared GPU access as well. Private agreements, as I mentioned already, we're definitely seeing some use for the technology for those types of use cases and for auditing as well. Here's a little whistle-stop tour. I'm not going to go through these. You can look at the slides afterwards, but there are many companies starting to get into this space. Here's the top 10 of the coins. They've formed this DCC alliance. So anybody in this space is in this decentralized computation, confidential computing alliance. And then we're starting to see in the decentralized AI space, similar types of companies coming together. And they formed this thing called the Decentralized AI Alliance, where it's a bunch of different projects used for sharing data and models that have come together. If you're interested in that, which I think leads in quite nicely to the next set of talks after this, here's a sort of an overview of the space of the overlap for decentralized computation and also for AI as well. In particular, this data layer for the data processing, a number of different options that have opened to improve performance, get cheaper costs, so you don't have to run all this logic on AWS and pay huge amounts of money for it. It's a very competitive marketplace using underutilized GPU resources around the world. So I think it's a huge opportunity for the construction industry to start using these technologies and understanding that they are there, they have some benefits. They're not perfect, they're very early stage and quite nascent, some of them, but it is worthwhile looking at when you're choosing a smart contract platform, smart legal contract platform, and also your decentralized distributed data processing. That's me.